Okay, welcome everybody. We are now live. Thank you so much for everyone who's already joined on time. For anyone who didn't manage to join the webinar, no worries. This is recorded, so you'll be able to rewatch this recording around the topic of maximizing material efficiency with Autodesk Fusion extensions. This is a webinar that Symmetry is running in partnership with Autodesk directly. So my name is Jonathan. I work directly for Autodesk. And I'll be walking you through what we can do with material efficiency and specifically nesting inside of Fusion. So we'll get going here. Now, just a brief look at the agenda. Before we get started, we want to check out some nesting basics to get going. So what is nesting and what are the capabilities of nesting as well? Who's it for? We'll have a look at an overview of Fusion. What is Fusion? If you have never heard of it, maybe you've never used it or you've seen the logo somewhere, but you don't really know what's behind it. I'll explain a little bit what a Fusion extension is and which other extensions there are as well, and what the manufacturing extension specifically is. And then we'll dive into the nesting workflow, and we'll do a live demo here. So I'm going to switch over to Fusion and show you how this workflow works, going from an assembled little audio rack to nested and manufactured part. And then afterwards, we're going to do a short recap and summary of everything that we've learned. Again, if you do have any questions, don't be shy. Post them in the questions section. We'll try to get to those questions at the end of the webinar, but in any case, you'll get an answer to those if you need them. Just briefly towards me, I'm Jonathan, so I'm a senior technical specialist for the Fusion team. I am based out of Barcelona, Spain. My background is in industrial design and product development. Before joining Autodesk, I used to have a small industrial design company with a couple of friends, and we used to develop products, specifically actually furniture and train lighting, of all things. And we used to do a lot of laser cutting and also a lot of milling in 2D. So I'm very familiar with nesting. I used to bring parts to be manufactured all the time throughout my studies and my early years of industrial design and manufacturing. I've been working for Autodesk for 6 years, though, as a technical specialist, supporting in the beginning the whole product design manufacturing collection with Inventor and AutoCAD and all of those things. But for around 5 years now, I've been focusing really only on Fusion and the Fusion industry platform that it's becoming. I would describe myself more as a generalist. I like to look at things end to end. So I do try to cover a pretty wide area of what Fusion offers. In addition to that, also, I have become quite proficient at production planning and execution, as this is also part of the Autodesk portfolio now. All right, let's get to the meat and potatoes of things. The nesting basics. Let's dive straight in and talk about what is nesting in the first place. Well, nesting is a principle, really, which is the process of laying out cutting patterns in order to maximize material utilization and to minimize waste. So two important parts, right? Where we have our designs, and we design them usually in a way that they are assembled the way they should be as a real product. And then we need to manufacture them. And in order to manufacture them, we have to lay them flat. And our material comes in certain sizes, which we want to utilize to its fullest potential. So we want to maximize that material utilization. And at the same time, we obviously want to have as little waste as possible. So we have these two goals of maximizing material utilization and minimizing waste. What does this look like in an example? And this is the one that we're going to go through later on as well in the live demo. We have this audio rack on the left-hand side, which is designed in an assembled state. So this is actually made up of a lot of sheet metal parts that are bent and folded into place, and they're designed that way. We also then create flat patterns for each of those sheet metal parts, of course, and those flat patterns are what I used in the nesting study. So here is our stock, where we have our sheet of material. It has a certain size, and therefore, of course, it accommodates a certain amount of parts for each of those sheets. Now, we need a clever mechanism that can do this automatically for us. Of course, it would be possible manually, but who wants to do that? Honestly, that is really, really tedious. And humans tend to be pretty bad at doing these sort of optimization tasks. That's what computers are there for. So we want to use computers for this. Why do we need nesting? Well, for one, like I mentioned, the part positioning. This is something that you could do manually, but as the complexity of your products grows or the amount of products grows that you need to nest together, positioning the parts efficiently on a sheet of material becomes very, very tedious, and that is something that is much, much better done with an algorithm. We want to be very efficient when it comes to the manufacturing. So we want to have a toolpath that will take the least amount of time, of course. That means also covering the least amount of distances, but also knowing when you have internal contours or external contours, for example. And as we see, throughout the supply chain globally, costs are rising for the material. There are material shortages in a lot of places, and therefore, obviously, we want to minimize costs always, but it seems to me that it's becoming increasingly important to really be very sort of dedicated to minimizing costs if we can. Who uses nesting? Well, there are many, many different possible industries that could use it. We see sort of three very typical ones, which is in sheet metal and woodworking and cabinetry. So we can see here that sheet metal is probably one of the most used ones. I don't know if you can still see my screen. I think there we go. Yeah. So sheet metal is very, very common because that is where a lot of these machines, so laser cutters, water jet, even plasma cutters are used. Woodworking is also definitely quite common, especially if you've got complex shapes, maybe some sort of more advanced furniture designs. And then also cabinetry, that's pretty clear. Everything is done with sheet material, plywood and things like that, where you would need to nest. But there can be many more subsets of these industries, things like signage, or sheet metal could be used to create custom trailers, enclosures. I've talked to customers that do barbecue trailers, which is quite cool as well. Snow plows, cabinets. In woodworking, that could be panel furniture or flat pack furniture. It could be sculptures even, or also signage again. In cabinetry, you have kitchens, bathrooms, offices, shelving, etc. And really the possibilities here are endless. And it's definitely not limited only to sheet metal. That is sort of what a lot of people jump to as a conclusion straight away when they think about nesting. But actually, nesting is used in many different materials. So it could be wood, like we see, but it could very well also be acrylics or dye bond materials or anything that is flat, essentially. I want to give you a little bit of an overview of fusion. What is fusion and what is it there for? Well, first of all, we have to understand the world around us, and we can see that the world is really changing very, very rapidly. In the news, we hear about AI being used all over the place. We hear about robots. Just yesterday, I saw a really interesting video of Boston Dynamics with their new robot out there. Things are starting to be automated. Well, not starting to be, they're continuing to be automated in all areas, from initial concept development through the design and engineering, through the simulation, the manufacturing, and the delivery to the customer as well. And therefore, we need to adapt as well to how the world is changing around us. We need to change the way we design and make things. There are certain challenges that we face as well, things like skills shortages. I speak to customers every day, multiple times a day, and I hear that it is so hard to retain our talent, but also to attract the top talent that has the knowledge to be efficient and perform well. We talked about rising costs just now as well, where across the supply chains worldwide, especially in regards to materials, we are experiencing rising costs, and supply chain can break down, and we need to be nimble and flexible when it comes to challenges here. However, we do also have opportunities. So, for example, smart products is something that comes up all over. We're probably all wearing some sort of a device that is smart or using it in our daily life. But these smart products are even carrying all the way through to the shop floor. In rising costs, we can really work with digitized processes. We can automate things. We can look at our processes that we've done manually and see, are there opportunities to digitize those and to understand more and make fact-based and data-based decisions. And cloud connectivity is a huge topic where we can alleviate common problems in communication and collaboration between companies, customers, suppliers, etc. Now, unfortunately, in the real world, it doesn't look as perfect as we would like to see it, the way we see a utopia. In the real world, we see that our customers design and manufacture with all sorts of different tools. And then their suppliers and their customers, again, use a whole different tool set. And there's a lot of breakdown of communication between different systems where we are dependent on using neutral file formats that lose certain information, and then things get lost in translation, and we're constantly waiting on things. And the reality is that way. It really is. But we need to understand that it is that way, and then we can work towards maybe changing that as well. Also, if we talk about technology all the time, we must not forget that who is driving the technology are people, and the people are at the core of generating value. So we need to recognize that we are giving our workforce our most valuable resources, the technology, to perform the best that they can. We want to generate the most high value work that we can and give the people better reason why. And therefore, what we have done at Autodesk is to create a platform that we call Fusion. And Fusion has at its core belief and as its reason to be to connect these common workflows, because we want to take the data out of these silos. We don't want an engineering team to work with their tool and not be able to hand it off efficiently to the manufacturing department or to procurement or to customers and suppliers, etc. All of these should work off of a common data model or a single source of truth, how it's often called. And this is where Fusion is not just one of those tools, it is actually all of these tools together. So it is design, it's simulation, it's electronics, it's documentation, it's manufacturing, nesting, additive manufacturing, etc. It's all of these things together in one platform. And that really makes it fast, it makes it very, very flexible, and it makes it connected. And that is the way that you would like to interact with your customers as well, of course, and how we would like to see the world in the future. Now, when we talk about Fusion, Fusion comes as a sort of a base package that already comes jam-packed with all of these different functionalities. However, there are certain functionalities that exceed the requirements of the base package. And that is where we have decided to take certain functionality and make it available inside of extensions to those people who really require that advanced capability or who need certain access to capability all the time. Now, who has been part of the Fusion journey already might have seen that there used to be Fusion extensions, quite a number of them, 8 of them in total, and it used to be called Fusion 360. It was rebranded to only Fusion, make it a little bit simpler, but also the extensions were repackaged. So if you previously, for example, had a simulation extension, then now you also get access to the generative design extension, and that is together called Fusion Simulation Extension. And in the manufacturing department, really the biggest change was made where there were 3 individual extensions for additive build, for specifically the print preparation of metal additive powder printing, the nesting and fabrication extension, and the machining extension for advanced toolpaths and toolpath editing, etc. And these were packaged together and put into one extension that is now cheaper than each individual extension was before. So it's become much, much more accessible, and it's much fuller in features than it used to be. So it's a really great time to go for a manufacturing extension now because it offers an incredible amount of functionality. These extensions, like I mentioned, are there to be able to extend your platform, to eliminate disconnection, to give you access to specialized technologies. This is all sort of on one platform. You can simplify your workflows because you can automate a lot. You enhance team collaboration. You shorten your time to market. And the best part is that it's really flexible to access these. If you need them on a daily basis, you can do that. You can do it on a monthly basis or a yearly basis. So depending on your needs, you'll be able to go to your partner, to Symmetry, and ask them about the best package for your needs. Like I mentioned before, 4 of these extensions, the design, manage, manufacturing, and signal integrity extensions, they add functionality. So they actually give you access to specific technology that you do not have access to without the extension. The simulation extension, including also the generative design, is seen like a flat rate. So if that is something that you do a lot, then it makes a lot of sense to go to that extension and you just simulate and generative design as much as you like within the time period that you've subscribed to. Just a brief look at the manufacturing extension, because this is the basis of what we're going to look at now in the nesting. Apart from just the nesting, you also get access to advanced toolpathing. So that includes things like 4 and 5 axis simultaneous toolpaths with really incredible technology that is hitting Fusion with every release every 6 to 8 weeks. Automated machining toolpaths. You can modify your toolpaths so you can edit them and cut away parts. You've got part inspection and automated setups. And you've got the associative nesting that we're going to check out, and the multi-sheet nesting that you don't have access to otherwise, and also the integrated 3D printing, so specifically for metal powder bed printing, and then also the print simulation to create an inversely deformed part to alleviate any part deformation through the additive process. So absolutely jam-packed in one extension. I think it's incredible that one gets access to this level of technology at the price it's offered at. Now today we're going to focus on the nesting part of the manufacturing extension. And here the goal is, of course, to reduce our programming time, to have automated part layout, also to have multi-part nesting, to reduce our costs and optimize material yield, and also be able to compare the material selections that we might need to make. And we want to minimize the amount of rework because we've got integrated CAD and CAM and associative nesting. So the nesting is adaptive to the changes that are made in the design department. Just a quick comparison, because I talked about the Fusion base package and the manufacturing extension, and this is specifically just on the nesting part. So in Fusion Core, there is a kind of a very, very light version of nesting, if you will, which is called Arrange. And that in your design environment lets you arrange parts on a plane. That will only take into consideration one single sheet, and it can be done on a sketch or on a plane or on a face of a part. And it is associative with updates. However, this is really quite dumb, if you will. It is helpful, of course, to have, but if you are doing nesting and you're really interested in optimizing your material yield, then you will want to go for multiple document nesting, be able to identify materials, thicknesses, the quantities of parts automatically, have the amount of sheets update automatically, have nest reports and comparisons, have a shared library of sheet stock sizes. So if you're working in a team, everyone is working off the common libraries of sheet sizes that you always have available. You can have the export of your nested sheet as well as DXF. You can have automatic remnant cut geometry. So there's a whole host of functionality that is part of the manufacturing extension, just in terms of the nesting that you get access to. Now, I want to jump into the nesting workflow. We've described all of the basics of it, and I want to show you now how this actually works. So we're going to jump into a demo and look at Fusion Live. And you can see here I've got this little audio rack that I described beforehand and has an example. And in the design here, let's have a quick look at the design. We can see that it's made up of several sheet metal parts over here. It's also organized in a couple of sub-assemblies that also, again, have sheet metal parts inside. Now, if we look at this whole assembly, though, I would probably not want to nest all of the parts out of this assembly, right? So obviously the sheet metal parts, they make sense. But if we look at the fasteners that are part of this assembly, or let's say the handle up here, also the casters, this is not necessarily something that I would like to nest. One of the most common frustrations that I see when people try out the nesting, and that is really regardless of which tool you use, whether you use Fusion or something else, is that no preparation goes into the nesting. And I want to show you first, before we do the proper way of doing things, what kind of an impact that might have, and then we're going to do it right. Okay, we'll go and fix it. So let's say we don't do any preparation inside of our design. In that case, if we go into the manufacturing tab where we create the nesting, we would go inside here and we would look at our process material library. So this is the tool that recognizes which of the materials are part of our nesting, and it's going to create a process material library automatically for all of the parts that we see. And you can see here, these are all of the different sheet sizes, if you will, or sheet thicknesses that it's finding. And obviously these are not very realistic. So what is a 24.765 millimeter sheet thickness, right? I don't know, this might be one of the casters, for example, or here 42 millimeters or 53. This is not something that we want. And it makes the whole experience messy and slow. So really the first part of going into nesting is to prepare the nest. And the way we do this is in the design environment, under utilities, there is the so-called nesting preparation. And this nest preparation is going to find all of the parts inside of our design and decide which of them are going to be nested. Now, by default, I've kind of tricked this for purposes of this demo. It is going to automatically ignore certain parts that wouldn't really be nested. And you can see how long this is taking here. So really by default, this algorithm is quite clever. However, I've switched this off. So it would actually find kind of all of the different parts. And this is always taking a really, really long time. So this is not necessarily what I would want to happen. Instead, what we do in our design here when we go into the nesting preparation is we let it automatically find in our selected entities what it should nest and what it should ignore. And I'll walk you through the different options that we can see here in just a second, just while it's calculating all of the nested shapes, and then we can walk through them together. So as it's finding the entities that I've selected in order to nest, it sees, okay, automatically this is a sheet metal part, and therefore it is taking the flat pattern of that sheet metal part and not the folded part, of course. For other parts, like here, for example, this is probably one of those little fasteners that we cannot see. Here are 39 of them as an example. It is automatically ignoring them. So there's also some electronics as part of this, this assembly here. And you can set up whether you want to ignore them or whether you want to include them in the nesting. That is up to you. Once you actually find parts that you do want to nest, then you can scroll down here and specify that it's going to calculate the thickness automatically. This is very useful, of course, because it's going to find all of the different thicknesses that you have within your design. and then it's going to create individual sheets for those thicknesses in the actual nesting study. What we can also see here as part of these different sheets that it finds is this little arrow here. And that is very, very valuable because it shows the component grain of that part. Now imagine for design purposes, I might have chosen brushed aluminium or brushed steel or something. And I, of course, want that in my nesting, this component grain is going to be utilized, because I don't want varying component grain just because the nesting study will be more efficient. For design purposes, I would want the component grain to be the same. So here, using this little gizmo here, you can just rotate the component grain to the direction that it should be inside of your design, and that will then carry over inside of your actual nesting study. So nesting preparation is really the first step, and I would encourage you to spend a little bit of time in making sure that the nesting preparation is solid, and then you'll have a great time in the manufacturing environment setting up the nest. Now the next step in the nesting environment or in the manufacturing environment is to actually set up the nesting. And the first step for that is to choose what are actually the components that I'm going to nest. So here we have on the left-hand side the component sources. When we jump in here, it'll list out those component sources that were part of the nesting preparation. So again, here we're saving a lot of time because we don't have to sift through an entirely long set of all of the different components and then choosing which ones are going to be nested, but rather we have here now all of the different panels to make sure that the component grain is the right way around. And if we need to, we can override quantities here. We can even override the nesting material. We can set a priority. This priority is going to be the first priority in nesting, actually. So if you do set a smaller number, so priority 1, that would mean it's the most important part to nest, and it's going to override whether this shape fits better on a different nest. It's going to nest this as a priority number 1. Then the component grain for the component, and whether it's going to be bound to that grain or not. And you can set up different settings in which way it's allowed to be rotated. If you want here, you can also add other components to this design. So you can actually select multiple sources from your designs or even from your computer. So you could set up different designs that you want to add on. These could even be DXF files if you'd like, and then they can be utilized as one nest inside of one nesting study. And that, of course, increases the efficiency dramatically because now you're not doing it on a product basis, but actually utilizing your sheets that you have available across multiple products. And that is also the way that I know nesting to be done at fabricators. They would try to get together a couple of projects and nest them, thereby utilizing the material to its fullest extent. Now we can have a look at the process material library, and in this case, this will be much, much cleaner, of course, because we're only finding the materials for the components that we actually did choose to nest in our nesting preparation. Now, part of these materials is defining for each of the material thicknesses how we want this to be nested. So a couple of general parameters over here. Density. Here we have our different packagings. So these are essentially our different sheet sizes that we have available. And we have the nesting parameters. These are important depending, of course, also on the process that you're going to use to manufacture and fabricate these parts. So item separation, for example, if you're using this more in a cabinetry world and you're using a router, for example, you'll want to use the smallest tool size that you would like to use to cut out the parts and use that as an item separation at least. Do you have a frame width? What is your material grain in X direction? Do you want to pre-kit? That means putting together two parts that together flipped around would would take up less space than putting them next to each other. This is something that's very well documented in our documentation as well. As part of the different packagings, you can see that here we can also assign a cost. And that's, of course, really great because we can then identify through the efficiency of our nest how much cost we're actually incurring for each of the parts, for each of the nests, for each of the sheets, and how much remnant we still have available afterwards. Note as well that over here you can sync from presets. So you can create presets for yourself. Once you have these materials inside of here and your different sheets, then you can go into the material and packaging presets and add your own preset that you can name yourself. And the great thing is that these presets are actually saved in the Fusion team in the assets folder. So this is something that is shared across your team. So if you're working with multiple users here and multiple employees have access to this, then they would be working off of a common material library. And that is, of course, very, very helpful because you don't need to maintain several material libraries at the same time. Now, the next step here is to actually create the nesting study, and we'll walk through the different options that we have in this nesting study over here. First of all, what is the job quantity? If you do have multiple projects that you want to nest at the same time, then you can choose whether you're going to have some projects multiple times and others only once or so. So you can have a multi-value. If you work in a stack, then you can stack up several in the Z height. In the shapes department here, we have access to viewing those shapes just to make sure whether these are actually those shapes that we want to nest. If not, then we can deselect any of them that we do not want to nest in this stage. In the packaging side, we can choose which of the packagings we would like to use. And if we do want to add any additional packagings, then we can simply add these up here. And we can also change the priority, which package should be used first. So we can move them up or down to prioritize the ones at the top. In the global parameters, we set up where this nesting is going to take place. Typically, we would nest to the lower left, but depending on your preferences, you can set this as well. And of course, you can play around with the parameters over here. I just typically use them as a standard here. Really, the maximum compute time, I've never seen this exceed a maximum compute time and stop. That would be for extremely large nesting studies. I haven't seen that yet. The remnant optimization is in order to create a remnant that best suits our needs for afterwards. So are we going to minimize the length, the width, length and width? That is up to us. And then we can choose whether we're going to create a manufacturing model and whether we're going to include the stock material. Now, the manufacturing model is a really intelligent way of essentially creating this layout as a virtual copy of your design. And that enables you to modify your nested study after it has been nested, if necessary. Let's create this and have it run through our different materials. This shouldn't take very long. So you can see here, it's creating one nest for each material, essentially. And once that is done, then we will see the different sheets that are inside of each of the different nested studies. So this is typically a really fast process. It's just making sure that it's going to be as efficient as possible. And here we go. Now we have our nest. So nest 66 is a certain material. Nest 67 is a certain material. If you want to see what this is actually, then you can open up this nesting information and just click on here and it'll give you the different information, what this is, what's the material size. So this is an important window to have open. And then inside of these sheets here, you can see these are all of the different panels that were actually nested on here. And as you can see, we actually required, for example, 3 sheets for the same material thickness in this nest that were created automatically. And this is something that you would not be able to do with arrange, as an example. Now, what's also important, of course, is to be able to report on this. So if you want to see how efficient, for example, your nesting was, and you might want to communicate that with your manager or have that just as part of your documentation, then you can have a look and create these HTML reports. HTML because it's just universally viewable, easily consumable, and it's going to contain all of the information that you need for the nest. So it'll contain the different sheet sizes, which of the parts were actually nested, the cost, the efficiencies, so true efficiencies, all of this information laid out beautifully for you to document, and then you can save that as an HTML file. Now, down the line, of course, from these nesting studies, what we would like to do is to actually manufacture these parts, right? So from here, what we would do is we can simply create the setup from this manufacturing model. And I mentioned the manufacturing model before. You can also edit this manufacturing model. So, for example, if for whatever reason I would want to move a component in a different way than it has actually nested, then I can do that even after it's nested. So that is really, really valuable. I think I've had customers who do want to make changes or maybe want to add a hole or a text or an engraving or something that doesn't appear in the design. Then this can be done in the manufacturing model that is created. And if we want to use this manufacturing model again to create a setup, then we can do so straight from here. And the nice thing is that it's now going to include automatically, of course, the stock material that we created. We'll select which of the models we actually want to manufacture. I'm going to use a cutting process. If you want to use this for milling, you just change it to milling, and that is no problem. We hit OK. Now we've got our setup, and we can then very, very easily create our 2D profile, select a tool that we want to use. In this case, I'm going to go for maybe laser cutting. So this is our tool library. You can set up your own libraries of tools and, of course, different cutting speed, presets, etc., depending on the material that you're using. And then depending on how you want to manufacture this, you can select the contours. You can select a silhouette, for example, as well, which definitely would also be a way to do it. In this case, I'm just going to select the face contour, edit this, and also select all of the other same plane faces. So it'll automatically create those. If we are working with tabs, then we can create those tabs automatically here. So for a laser cut, it's just going to pause for a second, move along and continue here. We can also set these up manually as well. So you can set up manual tab locations if this is something that you're interested in, and just add them in where you need them. Our heights and passes and so on should be fine. We'll just hit OK, and it's now creating our CNC toolpath for the nested study. So we've now gone entirely from a design to an efficiently nested study with all of the different sheet sizes that we need, to a toolpath, and then with the included post-processes inside of Fusion, you'll be able to pop that G-code straight to the machine, all in one tool. And this is what I was talking about, an entirely connected and associative platform, where we just see that breaking down those silos where otherwise, previously, you would have used 3 tools for this, in the design part, in the nesting part, and then in the actual toolpath creation and post-processing. This is now all in one associative platform. Okay, moving on over here, I just want to give you a quick recap and summary, and then open it up for questions if there are any. So again, the manufacturing extension, it contains also the advanced milling side of things, turn mills, 4-axis simultaneous, 5-axis simultaneous, toolpath editing, probing, etc. But we talked today about the nesting part. We have amazing benefits of avoiding rework because it's associative to the CAD model. There's integrated CAM that we saw just now. We can predict the material usage and optimize the yield, because we can also set up multiple studies if we'd like that and compare them with each other. We can estimate the part production costs, so that really aids in calculation and also post-calculation. It's very flexible and easy to set up for beginners and for experts. And yeah, it's pretty fast. It's easy. It creates multi-sheet nests. You have the process material management and optimization, so you can make sure that everyone is using the same sheet sizes that you have set up for your company. You can easily compare for quoting and create those comprehensive nesting reports. I guess thank you so much for joining, everyone. It's been a pleasure sharing this with you. I hope that all of the participants can find value in this workflow of nesting parts and maximizing their material usage and reducing waste.